This is the video lesson for work energy theorem. The learning target for this lesson is I am learning to investigate work in terms of energy transfer using the work energy theorem. The success criteria for this lesson are I can characterize the work energy theorem in words and mathematically. I can explain how work is the transfer of energy, and I can compare how the work energy theorem functions in conservative and non-conservative situations. So what is the work energy theorem? The work energy theorem says that the work done on an object equals that object's change in kinetic energy. So objects only gain energy when work is done on them, and objects that have energy can do work. So an object that's up high can do work because they have energy, and objects that have work done on them, so say a roller coaster car that has moved up a hill, it's gaining kinetic energy as it goes up the hill. It is also gaining potential energy. It can do work, so as it rolls down the hill, it can do work. So the formula for the work energy theorem is W equals delta KE. So W stands for work, delta KE stands for the change in kinetic energy, and delta KE, if we look at that more specifically, means that the final kinetic energy, so KEF minus KEI, so that's the final kinetic energy minus the initial kinetic energy. So let's take a look at this in conservative versus non-conservative systems. So the work energy theorem is only valid in conservative systems. In non-conservative systems, some of the work done on the object will be lost as heat due to friction, so not all of the work is converted into kinetic energy. So for a couple of examples, I have the first example is a cuckoo clock. So if you've ever seen a cuckoo clock or even a grandfather clock is the same idea. You've got a pendulum that swings that helps do the timing for the clock. And then you have these weights. The weights hang down and as the weights move down as the clock is ticking, that is what determines how all the mechanisms work inside the clock. So the weights are basically providing energy for the clock to work. And when the weights get to the bottom, when they get down to the ground, you wind the clock by moving the weights back up to the top, and then you let them go again, and they start the whole system over again. So the weights moving down to the bottom create basically the energy inside the system to power the clock. So as you do work, you move the weights to the top of the clock, and that creates the energy to make the clock function. Another example would be a roller coaster. So the roller coaster car uses energy to move to the top of the big main hill. And so that is doing work to get the roller coaster car to the top of the hill. And then that energy that is at the top of the hill can then be used to have the roller coaster car move throughout the rest of the roller coaster. So that energy is converted from potential energy to kinetic energy for the rest of the whole roller coaster. All right, everybody, go out there and keep asking questions. It's how you learn new things.